Good morning, students. I am Disha Roshan Bhakta, Assistant Professor, Department of Information Technology, Bansanga, City College of Science, Commerce and Management Studies, Powai. So today we are going to start with intelligent agents. That is the next part of our subject, artificial intelligence. So going backward again, so okay, we have seen the introductory part of our subject, okay, and in the introduction, I think we have seen about the definitions of artificial intelligence. Then we have also seen about the different foundations of artificial intelligence. We have also seen about state of art of artificial intelligence. Okay, we have also seen about the history of artificial intelligence, and we also have seen about characteristics of artificial intelligence, okay, which is basically about thinking humanly, thinking rationally, acting humanly, and acting rationally. So that was a very quick revision of the concepts to what we have seen through. Okay, so students, today we are going to see something more about agents. So if you remember that in one of the historical section which we have covered in our previous lecture, okay, what we have seen is that uh, basically into the recent scenario, artificial intelligence, okay, uh, it's more into creating intelligent agents. So today we are going to actually understand what do the concept of agent means, okay, and what is agent and environment, what is going to be the environment for agent. Okay, we are also going to see about what is rational agent. We are going to see about concept of rationality, and then we're going to take a very small example of vacuum cleaner agent. Okay, I think we have a very small discussion about it into our previous session, and lastly we're going to end the session with something known as peace. Okay, so that's what we are going to see today. Okay, so let's start. Yeah, so now, agent. An agent is anything that can be viewed as perceiving its environment or surroundings through sensors and acting upon that environment through actuators. Okay, so an agent can be anything. Okay, if we talk the very layman example of an agent, I think we all behave as agents only. Okay, so that is the very layman example of an agent. That is nothing but we can call it as human agent, wherein what is the process or what basically an agent does, what is the major activity of an agent is that it will perceive from the environment or the surroundings through sensors. Okay, through sensors, and then and acting upon the environment through actuators. Okay, the very brief meaning of sensors and actuators, I think students, that we all know sensors is something which takes input, and actuators is something which gives output. So similarly, okay, what we're trying to say over here is that if an agent can sense the environment, okay, maybe using sensors, okay, and then acts again upon to the same environment using actuators, then that concept, okay, or that thing is actually known as agents. Okay, so here if you see there is a very small diagram, okay, which tells that there is a agent. Okay, it could be a human agent, it could be something else. What it could be, we'll see in a short time. Okay, but yes, it has a sensor, and if you can see over here, an eye is being shown, which is nothing but which can take input, and the percepts are received from the environment. So an agent will always have a certain meaning. Okay, if the agent is working in an environment, if an agent is just sitting idly somewhere, it's not going to receive any input, neither it has any meaning to give the output also. So over here, if you see that environment is also very 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 important, basically the most important thing, because it's from there only agent is going to understand that what has to be done. So what we see over here, the percepts are received from the environment, and the agent is taking the percepts, making use of the sensors. Okay, so percepts and sensors basically, are going to combine the input for the agent. And then what we can see is the hands and legs are being shown as effectors, or we can say actuators. And then that actions or that output is being again, thrown back to the environment. So that's the definition of agents. Okay, that's a rough definition of agent. Okay, the agent could be anything. Okay, the agent could be human, or something related to a machine also. So that we're going to see in some time. So, but that's what agent is. Okay, so I think in a previous session also we discussed that when we talk about agents, we talk more about perception, we talk more about taking input, and we talk about giving the output. Okay, so that's what the definition of agent is. Yeah, let's go ahead. Now, types of intelligent agents. Okay, so there are multiple types of agents, but the very brief categories of agents, okay, which exist, okay, are the first one, I think the same example which we have seen, that is a human agent, and I think we all are very well aware of. I think we are an example of human agent. So human agent has eyes, ears, and other organs for sensors, and hands, legs, vocal tract, and so on for actuators. So as a human agent, okay, we also have to take input from the environment, and maybe give out, and maybe we also give the output to the environment. So what we are doing right now, maybe I think in this learning process also, I think we are having, or we have the same approach. What we are doing is we are taking certain input, and yes, we are also producing certain output. Okay, so the human agent, the input would be taken via certain sensory organs like eyes, ears, etc., etc. And that's why those organs are also being told as sensory organs. Okay, because they're capable of. Now in case of human, at times it do happens that certain parameters behave as sensors also, and certain parameters behave as actuators also. And yes, that is the same case when we are going to look about the other agents also. So it might be possible, students, that certain things can behave as sensors also, and the same thing could behave as actuators also, depending upon they are acting under which scenario. Yes, so that's what about was about human agent. Okay, going ahead, the next agent. Okay, that's what is relevant to our subject. That is nothing but a robotic agent. So now what do the robotic agent have? The robotic agent have cameras and infrared range finders as sensors. Okay, so the robotic agent would be having sensors as cameras, or maybe a certain infrared range finders, which can detect certain things from a small distance. And yes, it could have many more things than that, but this is something basic, which probably any robotic agent would be having. And various motors as actuators, because there could be multiple actions which could be performed by robotic agents, so therefore we have listed down various motors. Okay, because it could be basically a motor which rotates the arm or hand, a motor which is capable enough to make the legs walk, or a motor which basically does certain things else also. Okay, so that's what basically a robotic agent means. Now, a software agent. Okay, so what exactly a software agent is? Okay, so the only difference what we can see between a robotic agent and a software agent is that probably the software agent, okay, will not have much hardware components into it, okay, as compared to robotic agent. But yes, what we see over here, that a software agent is also capable of behaving as agent. So how exactly it happens? So a software agent will receive keystrokes, file contents, and network packets and sensory inputs. So the software might receive a file, or maybe some certain packets from the network, or certain keystrokes from the user. And then what it does is it displays certain information on the screen, it writes certain information into the files. It also sends the network packets depending on what packets are, so let's say if it has received certain data from the network, okay, it will respond back to that also. So that's what a software agent is, okay. It's again taking the input and it's again acting onto the environment. So that's what was the types of intelligent agents. Okay, the brief categories are human agent, robotic agent, and software agent. So these are the very brief categories. Why I'm saying brief categories? Because again, these robotic agent, there could be multiple different scenarios in which this robotic agent would be created, and in all the in all these scenarios, there could be variety of sensors and variety of actuators, and same will be the case with the software agent also. But the basic thing that we want to focus over here is that whenever we are talking about an intelligent agent, there would be sensors and there would be actuators and there will be perception from the environment. Okay, what exactly this perception is, what we are talking about, we are going to see. Okay, so students, that was about intelligent agents. Fine. Okay, let's move ahead. So certain terms which maybe we are going to use in this session, and probably these terms we are going to use in a couple of sessions, and also maybe throughout our subject at any moment of time. So the one term, okay, that we already learned now is about agent. Agent is something, which we may be using throughout the subject. So we now should be very well aware about the definition of agent, that it is nothing but it is a certain thing which is going to percept from the environment through sensors, and then it is also going to react upon to the environment through the actuators. So now, what do we exactly mean by percept? Okay, so as we have already seen, students, into the diagram, that percept is nothing but uh, input, okay, received by the agent at any given at any given moment of time. Again, it has to be understood over here that agent will always receive input from the environment. So environment again itself is a very big thing and very important thing when it comes to the functioning of agent. So once we are going to, talk about agent, our next discussion will be more onto the environment, because if we have seen that there are only two entities which are very much relevant, and because of these two entities only the entire thing works, that is nothing but the agent and the environment. Okay, so the agent will always be embedded with sensors and actuators, and the environment will be an independent entity which would be behaving on its own self. So percept is going to be, when agent is going to interact with the environment and take certain inputs from the environment, that is nothing but we call it as percept. What is percept sequence? So complete history of everything that agent has perceived till, which means all the inputs that agent has taken till now, okay, that will frame as percept sequence. So let's say, for example, here we are trying to tell is that an agent is working, okay, and let's say the agent has been made before 1 year, and before 1 year the agent has started working. So it is going to store history about all the input that it has taken from the environment. Now here a question would arise in all our minds, that why we would need percept sequence. Okay, so maybe we can discuss on it, and that is something very relevant, and that is something because of which we can say that the agent will start about the learning process after certain moment of time. So yes, it is very important that the agent should store the percept history, or okay, and that is nothing but we call it as percept sequence. Now students, if as humans also, okay, yeah, maybe we also have an habit of percept sequence. Okay, whatever input that we have taken, we have everything stored into our mind. Now because it is a human mind, it might happen that certain input may have more emphasis and certain input may not have more emphasis, or maybe certain input is is something which we remember, and certain input is something which we don't remember. But students, that won't be the case when we talk about maybe a robotic agent or software agent or something like that, because that is nothing a choice based over there. They don't decide that this is something which I have to store and this is something which I don't have to store. So there will be a whole lot of data collection over there, and they're going to just simply they're going to store it and store it. So whatever input they have received, they're just going to store it over there. So that's what about percept sequence. Okay. Now, so the in percept and percept sequence, we talk basically about input, right? We talked about input, and we also see that we have also seen that after taking the percept, the agent has to give certain output. So basically, how does it happen? So it happens using something known as agent function. So what an agent function is, it will map from percept histories to actions. Okay, so it is nothing but we can say and an algorithm made to a code, okay, which will help the agent that if this is the percept, then this is the relevant action which has to be taken. Okay, so agent function is nothing but we can say maybe a function or a certain algorithm which is going to basically help to map the percepts to action. And then what is agent program? Okay, so an agent program, we can tell it that it is nothing but the subset of agent function, wherein the program is going to help the agent for the agent function. So at what different times basically that at what different times basically that agent function needs to be created, so agent program is going to help over there. So yes students, that was basically about what we call it as agent program. So these terms are very 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 important: percept sequence, agent function, and agent program, and we are going to use it throughout. Okay, let's go ahead. Now, rational agent. Okay, so just before few minutes we talked about intelligent agent, and now we are coming up with a slight change into the name, that is what we call it as rational agent. So what exactly is the difference, or what do we mean to say by the word rational? Okay, so now we are already aware of that what agent is, but when we are emphasizing on a word rational, what exactly do we want to tell about it? So now a rational agent is one that does the right thing, which conceptually means every entry on the table for the agent function is filled out correctly. So the line is a bit technical, but I'll just elaborate it. It just wants to say that when we use the word rational, which means that the agent does not have any chance to do something wrong. Okay, and that can only happen when agent is very well aware about that. Okay, if this is the percept, then this is the right action which has to be done. If this is the percept, then this is the right action which has to be done. Which means if there is a big table in which the input and the corresponding output is stored properly, okay, it's stored immensely, then in that scenario the chances of agent of doing something wrong will drastically reduce. Of course we can never say that it is going to behave 100% in all scenarios, neither we do, but in most of the cases, okay, so the ratio of doing the right thing is going to be very 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 high. And that's what is expected when we are going to make agents artificially. Okay, so what is expected is that in most of the scenarios the agent should always behave in appropriate manner, and these can only happen if the table for agent function is filled. So what was agent function? Agent function, students, was nothing but it was going to map the percept to actions. And so if I have the proper information about the input and proper information about what output has to be taken, then it's going to work out properly. So we will understand these concepts again in more detail when we are going to take examples of certain agents, and then it will be very relevant to talk about these line again over there. Fine, let's go ahead. So what is another next characteristic of this rational agent? For each possible percept sequence, a rational agent should select an action that is expected to maximize the performance. Okay, so whatever action the rational agent is going to take, it should be in such a way that the performance should be maximum. Okay, the output should be best. So that's why that agent is known as rational agent. Now, rational agents have to be well aware of the percept sequence and also the knowledge base of their own, and with respect to that, the best action will be taken. So the this point wants to tell, okay, this point is nothing but the summary of the first two, that if you want that, it has to it has to behave perfectly, it has to select all the action very well, then in that case, the knowledge base, okay, now what exactly is knowledge base, okay, so it's nothing but going to be the, we can say, a kind of a database or a data set, or maybe a big sort of data collection wherein the inputs and the corresponding outputs will be stored. So it will be only possible that if the rational agent is aware about what is my input and what is the best output which I have to take. So if those all things are fed properly into the rational agent, yes, then only it is possible that it can be able to select the best action. Yes, of course, one more thing is there, that whatever actions the rational agent is going to take more, okay, and whatever new inputs it's going to receive, so that are the certain things which will be stored dynamically. So the table of for agent function, or maybe the data collection, is always going to grow and grow. So as and when more the agent performance will be there with respect to the environment, the data collection is always going to grow and grow, and that's how the agent maybe start working more, start giving more better performance maybe than the previous one, because of the more data collection which is there. So students, that's what was about rational agent. Okay, let's move forward now. So yes, this is nothing but the same thing. So when we say rational, what we expect. So the concept of rationality simply means good behavior. Okay, that whatever action should be there, okay, that has to be good enough. That should not be something which it's not thought of. So when we talk about rationality, okay, we are talking about majorly four things, okay, or major four parameters are there which are needed when we want to make, or we are in a process of making a rational agent. So what are they? The performance measure that defines the criteria of the success. Okay, we will be students seeing about this word performance measure in just a couple of minutes, because next coming examples we are taking for the same. So yes, when we say that these agent is behaving as rational agent, then we have to define what is the success parameter of it. Okay, so let's say if the agent is doing certain thing, okay, and for us the success criteria of this agent is also that the same thing should be achieved. Then yes, we can say that the agent is behaving as rational agent. Okay, so let's say example in a game of a chess, the criteria for us of the success is to win, and the rational agent, the performance measure of the rational agent is also to win. Yes, in that case we can say that the agent is behaving properly, the agent is behaving rationally. But let's say taking a certain change into this example, for us the criteria of success is, let's say, winning, and the performance measure with the rational agent gives is time, which means the time consumption for taking the next step is very less. But what happens at the end is there are the chances of winning are less, or maybe out of 10 5 is win and 5 is lose. Then yes, in that case maybe we need to improvise on this agent, because then it's not exactly behaving to the concept of rationality. Okay, so in that case also we will call that yes, it's behaving as agent, but it's not up to our performance measure that we define for our success, or we define for the success of the agent. Fine. The agent's prior knowledge of the environment. How much agent is aware of the environment priorly, which means before agent starts its working, okay, there has to be most information about environment already fed into the agent. In this scenario, the agent can act as rational agent. The actions that agent can perform, so whatever actions which the agent can perform, so the more better actions the agent can perform, we can call it that this is the concept, or it's going to behave as rational agent. And the agent's percept sequence to the date, how well the agent is storing the historical data regarding the input that the agent has received. Okay, So students, that was basically about, the concept of rationality, and that's what the meaning of rational agent means. Fine. So let's go ahead. So we are going to see an example of a vacuum cleaner agent with two locations. Okay, so this is going to be a very simple example, and yes, we are going to take this example forward also in our coming lectures, and in that scenario we will understand that it becomes somewhat more complex after a certain amount of time. But in today's discussion, it's very simple. So there's a vacuum cleaner agent, I think, which is already visible onto the screen. Okay, there are two blocks, that is square A and square B, which are nothing but the location. And then, we have to just understand that in this scenario, because we have termed it as agent, what is the percept, what is the action, what is going to be the environment, what should be the percept sequence, etc., etc. So what we see, the environment is nothing but square A and square B. Okay, or we can also term it as location A and location B, because it's the place where the agent is going to work. What are the percepts? Percepts means what it is going to take the input from the environment, location, where exactly the agent is, and content. Content in the sense whether the dirt is there or the dirt is not there. So that's what is content. Okay, so you can of course replace the content with dirt also, but it might also happen that the agent would not find anything. So that could also be the case. And what could be the possible actions, which means what could be the possible output after receiving the percept. So the possible output could be either the agent will move left, either the agent will move right, or it will suck up the dirt, or it may not do anything. So that's what about vacuum cleaner agent with two locations. Yeah, I hope students the example is quite clear. Okay, the environment, the percepts, and the location. Fine, let's go ahead. So now we are talking about the percept sequence. Okay, so percept we already understood that either it could be in A or it could be in B, and that could be the location percept, and the content could be either it could have find the dirt or it could have not find anything, which means it would be clean. So that is going to be the percept. Now percept sequence. So let's say it has started working, and what input it has started receiving. So let's say the first percept sequence is when it's in A and it found that A is already clean. Okay, so which means it is in certain location of A and it has found that it's already clean. Then the action says that okay, then move right. Okay, then again when it has moved ahead, what it has found that that portion is dirty, then the action is said suck. Okay, now let's say it has moved to B. Okay, and it has found it clean, then it is saying that move left. And again let's say it, going forward it has moved again in B and it has found dirty, then the action is suck. Now this is where the percept sequence is playing a role. So A clean, which means the previous previous instruction for A was A dirty, and because it was stuck, now that part of A is already clean. So that's what you see that is appended, and then the next percept or the next input that again it has received, that moving forward. So when you are saying that there is two A clean, the previous one is telling you that the previous one is trying to tell you that that was the previous percept sequence that was has happened previously. Okay, and it has stored previously. A was dirty, it has done suck, and that's why now that portion is clean. So that it has stored because it has moved ahead, it has to actually clean the whole A block, and that's why the whole A block would be divided into multiple locations. So what it is trying to do is that whatever portions of A are already clean. Okay, see, when you just write A, it will not be simply A. Okay, it will be certain exact location of A. Okay, so but that depth is not being shown over here. So when A clean is written, which means certain coordinates or certain values are written in which it is trying to tell that these till this part the cleaning process is done. And now what is happening, it is moving ahead and the next percept sequence. Okay, what it is seeing that okay, that is clean. Okay, so in that case it is trying, okay, if this is the case, then let's move ahead. Okay, so again previously it has moved ahead, and then was that till that coordinates or till that location the things were clean, and then the next now moving ahead, what percept it has received that it is dirty. Okay, so in that case it will say suck. So students, now when you will see, it all depends upon how long percept history. So what will happen, maybe once again it will move into the A block, it will say A clean, A clean, A clean, which means a series of 3 to 4 coordinates which it will show that are already clean. And moving forward, it will again, try to find out whether it is clean or not clean, and depending on that, it will take the action. So the role of percept sequence is very important because it will try and help the agent to store what has happened to the agent into the past series of the inputs that the agent has taken. Okay. So yes, students, that was about the example of vacuum cleaner. Okay. Uh, Fine. So I think it's pretty much clear, and yes, we are going to go through this example maybe into much more detail and into other variations of it, how how the algorithm of these kind of agent is actually going to work. These all scenarios we are going to see into our coming sessions also. Fine, let's go ahead. So the next thing is, okay, that PEAS of agent. Okay, now when we want to say PEAS, what exactly it is? Okay, so PEAS is nothing but four criteria about an agent, that is performance measure, environment, actuators, and sensors. Again, students, if you see over here, these all words are already we have seen before some time: performance measure, environment, actuators, and sensors. Okay, fine. So now we are going to discuss about the PES using certain examples, okay, using certain scenarios, and let's see how well we could understand it using them. But the important thing over here is that you have to take an example of an agent, and then only you can understand all these scenarios. And that agent could be a rational agent, okay, could be an intelligent agent, or a combination of both of them. Okay, it's always expected that the rationality should always be the part of the agent. So now, the very first example to understand PEAS we are going to take is of the taxi driver agent. I hope you can understand what it simply means. Okay, so when we are writing agent over here, of course we are talking about intelligent and rational and artificial agent. Okay, so what is the performance measure? Okay, how will I say that this agent type is behaving properly? So let's say if the drive is safe, if the drive is fast, if things are legal. Okay, legal in the sense that if there is a signal and the signal is being seen properly and nothing wrong has happened over there, if there are tolls and then those things were properly crossed, if the trip to the passenger was comfortable, if the profits could be maximized, these all will be nothing but we can say the performance measure of driver agent. Again, the performance measure could be certain more, certain less, depending on what exactly was your requirement when you have created that agent. Where have you created that agent for a non-profitable thing, then yes, maximized profit will not be a part of it. Okay, but yes, being safe, being legal is something, whether you want to earn profit or you don't want to earn profit, these are always going to be the performance measure. So performance measure do change depending on the need why we have created that agent. Now, what will be the environment for this agent? Roads, traffic, pedestrians. What would be the actuators? How it is going to give the output? By steering, by accelerator, by brake, signal, horn, display, etc. And how it is going to sense? Using cameras, GPS, engine sensors, speedometers, etc. So this is an example, how the PES of the agent should be there. Now, whenever we are in a process of making a rational agent, this is the very first thing, which has to be defined. When we talk about making a software, we define certain things that, okay, it has to do this, it has to do this. But then when we talk about making an artificial agent, then this is the very, very first and important parameter which will help us to understand what is exactly we are expecting from the agent, and these will then help us to break down that how we can start performing it. Okay, so that's what about the example of taxi driver agent. Next is medical diagnosis system. Okay, so again it is going to behave as an agent. The performance measure is that the patient should be healthy, the cost should be reduced for the patient. The environment is patient, hospital, staff, because these type of agents are also being nowadays a part of hospitals also. Actuators, display of questions. Okay, display of questions which the medical diagnosis system is going to ask to the patient. So for the medical diagnosis system, it is going to be output. Okay, test. Okay, after getting certain answers, it will suggest test, diagnosis, and treatment. So these are going to be actuators. And what is sensor? When patient is giving answers, so that is nothing but the input for the medical diagnosis system. And whatever the symptoms of the patients that we come through know through their answers, or through that maybe type the queries, that are nothing going to be the nothing but the sensors for the medical diagnosis system. So students, again, if you see for medical diagnosis system, these are going to be the performance measure, environment, actuators, and sensors. Fine, let's go ahead. Part picking robot, I think, yeah, this is something we have seen long back in many ads of maybe uh, uh, certain companies that manufactures chips or manufacture computer parts or something like that. So part picking robots are always used when there are parts, okay, multiple parts which has to be picked up and then fix that particular location. And at times these are very important when the parts are very minute, and they have to be organized into a certain area. So then what is the performance measure? Percentage of parts in correct place, or maybe the percentage of parts picked up correctly, something like that. So again, it 100% depends upon what kind of agent it is, whether the agent is just about picking up the parts, or maybe fixing it also. So depends on that, the performance measure will be there. The environment will be the conveyor belt, okay, with parts. So there will be a belt on which continuously the parts will be moving, and the agent has to sense it that this is the part which has to be picked up. So that would be the environment. uh, the actuators would be joined arm and hand. Okay, I think you can very well imagine. And the sensors would be camera and joint angle sensors. So this is going to be the PES of part picking robot. Fine, let's go ahead. So the last example of PES that we're going to take is the interactive English tutor, in which the performance measure would be either the student's score on test of English, or maybe how well the students have understood the English. The environment would be the set of students, and maybe certain agency which has installed these kind of interactive English tutor. Actuators would be, what would be the output these kind of interactive English tutor would be giving, will be understanding of grammar, corrections, certain exercises will be given to the students to complete. And the sensors would be the questions of the students, which could be either asked by vocal, or which could be asked by the keyboard entries. So students, that's what was about PEAS. Again, if we just quickly go through back, then PES of an agent is nothing but the performance measure, the environment, the actuators and sensors. And these are the four important things which are always going to be associated with the agent. Okay, so we saw an example of a taxi driver agent, medical diagnosis system, part picking robot, and interactive English tutor, right? So yes, if we see about today's session, I think we understood about the concept of agents, okay? And then when we saw types of agent, we saw that there could be a human agent, a robotic agent, or a software agent. Then we talk about how agent and environment are connected to each other. So agent is always going to receive the percepts from the environment, and it's also going to give the output to the environment through the actuators. Then we saw about what is rational agent. So it is something which is always going to do the right thing. And about the concept of rationality. So in concept of rationality, we understood that it is always going to be the good behavior. It's always going to behave into the best version of itself. And then finally, we understood peace, that is performance measure, environment and actuators and sensors, with examples of certain agents like interactive English tutor, or part picking robot, or medical diagnosis system. And yes, the taxi driver agent, etc. There could be, yes, many more examples like this which we can take, and which we can think of, and then we can write the performance measure and environment and actuators and the sensors of them. Fine, students. So that's what was for today. Thank you, students. Thank you all. Thank you.